everyone, thank you for joining today's webinar. We will be doing a methodology breakdown of Verra's VM0044 methodology, which focuses on biochar utilization in soil and non-soil application. The agenda for today is we're going to go over a little bit about Envision blockchain, a Guardian overview, recap of previous webinars, our policy development checklist, then we'll do an introduction of VM0044, go over biochar utilization, how emission reductions are calculated, and then we'll talk about properties, schemas, and workflows, and we'll do a quick demo of VM0044. Before we begin going into methodology specifics, let's do a quick overview of who we are. Envision Blockchain Solutions offers expertise in the Web3 space, specifically in building and maintaining applications that help our organization navigate through their Web3 journey, with our specialized focus on guiding organizations through the three major milestones of use case analysis, proof of concept development, and scaled deployments. We're uniquely positioned to help our clients achieve their Web3 goals. And with our expertise as the builders and maintainers of the Guardian, we offer insights and support to ensure that our clients stay ahead of the curve in this fast-moving and dynamic space. So as you may know, the process of designing and collecting the supporting data for carbon claims is heavily manual and prone to errors. This can be due to a variety of factors, including poor data quality, a lack of assurance, potential double counting, greenwashing, and an overall lack of trust. The Guardian is here to address these issues by leveraging a cutting-edge policy workflow engine. The Guardian can mirror the standards and business requirements of regulatory bodies, creating extremely flexible digital methodologies known as DMRV. This approach not only helps organizations ensure compliance with regulatory requirements, but it also enables them to streamline their carbon accounting processes, improve data quality, and reduce the risk of errors and inaccuracies. So to the right here, you can see an example of our policy workflow engine, and you could think of the policy inside of the Guardian as a digital version of a methodology. And by using the policy workflow blocks like Legos, you could design your desired workflow. So we'll look at this towards the end in our demo and see what these different components are and what you can use to build your own policy on the Guardian. So at the heart of the ecosystem are four key technologies that enable us to deliver trusted and transparent solutions for the carbon market. First, we use W3C decentralized identifiers that we'll call DIDs. DIDs are globally unique IDs that allow individuals and organizations to generate their own identifiers using systems they trust. By using DIDs, we can ensure that carbon credits are issued to the correct party and that they cannot be duplicated or manipulated in any way. So we know exactly who are receiving these credits, or any step that was taken within the workflow will also have a DID for that. So second, we use W3C verifiable credentials. VCs are digital documents that provide information related to the subject, the issuing authority, the type of credential, specific attributes of the subject, and evidence related to how the credential was derived. We'll also see this at the end of the demo where we see our trust chain, and we have a VP that would have all the VCs in there, and you can open those and see all the information that was filled out by the different roles, like a project participant or the VVB or the standard registry. And then finally, we have our VPs, which are a collection of one or more VCs. So we're going to do a quick recap of our past webinar. We've been doing webinars since February, and we host these monthly as part of our methodology breakdown series. Each webinar focuses on a specific methodology from our open source library and is aimed at helping our users and anyone interested in the Guardian to understand how these methodologies can be streamlined for efficient implementation. And we've covered like Verra's 17, which is for the adoption of sustainable agricultural land management, the M42, that was for improved agricultural land management. So those two are very similar. Then we did a comparison of Verra's afforestation, reforestation, and reveg methodology versus the gold standard afforestation, reforestation methodology. Then we've been doing some of CDM methodologies that include our ACM0003. That's also for afforestation and reforestation. We've done AMS3R, that's for fossil fuel-based lighting with LED CFL lighting system, so substituting those two. S2G. And the last two we've done are AMS3D, which was for methane recovery and animal manure management systems. And finally, AMS3BB, which was for electrification of communities through grid extension or construction of new mini grids. So all of these will be available in our open source library and can be used there. Now, looking at our policy development development checklist. This was created by our ESG consultants, and this is a simplified checklist of the steps that we personally take in order to create these digital methodologies, or DMRB. So we start off by identifying the standard and appropriate methodology. So this could be Verra, Gold Standard, IREC, we have CDM as well. Once you've selected that, you can look through their standards and methodologies and select one of those where you want to make sure you read that document so that you could identify roles, processes, and requirements of that standard or the methodology itself. Then the fourth step here is to identify the input parameters and equations of the methodology. This is going to be really important when it comes to calculating all the parameters that are needed in order to get to your emission reductions. The fifth step is to create a workflow and schema, and we'll see this later in the presentation where you'll understand more of what we mean when we say identify roles, processes, and requirements. That's what we outline in our workflow. And then the last step is going to be to build a policy for the Guardian. We're going to move into an introduction of form, which again is a methodology for biochar utilization in soil and non-soil applications. So typical projects for VM44 would include project activities that consist of three parts. One is going to be the sourcing of waste biomass, two is producing biochar, and three is utilizing biochar in soil or non-soil applications, which I'll talk about in the next slide. The type of GHG emission mitigation action is going to fall under sectoral scope 10, which is waste handling and disposal. And this methodology is also for GHG removals, and that's why we have an emission reductions calculation in there. The tools referenced are going to be C8 tools that include tool 3, 5, and 12. These are all included when you fill out the form for this methodology. They're used to calculate specific parameters that are outlined in the methodology itself. So tool 3 is used to calculate project or leakage CO2 emissions from fossil fuel combustion. Tool 5 is for baseline project and or leakage emissions from electricity consumption and monitoring of electricity generation. And tool 12 is for project and leakage emissions from transportation of freight. So a little bit about biochar utilization. This is just a quick summary of what it could be used for. So here we're going to see a list of benefits for soil application of biochar. It can help with soil enhancement, enhance plant growth, increases soil water holding capacity, suppress methane emission, support soil microbial life and biodiversity, reduce nitrous oxide emission, reduces fertilizer requirements, reduce leakage of nutrients, stored carbon in a long-term stable sink, reduces soil acidity by raising the soil pH, increase soil microbial respiration, and helps plants resist disease and pathogens. So I included this image here. I thought it was a good example of what biochar could do for soil. So to the left, you'll see plants that were grown with soil as well as biochar, and to the right you have plain soil. So as you can see, the ones at the left grew a lot faster, they look more full than the ones on the right that only has plain soil. And this is an example, just one example of what you could do with biochar for soil application. But we can also use biochar for non-soil applications, and the methodology covers these as well. So here at the right we have an image of what we could benefit by using iron-rich biochar and treating asphalt. So to the left, we see it's going to be helping with suppressing emissions, but to the right, we just have regular asphalt that's going to be putting out emissions into our atmosphere. So some of the benefits of char in non-soil applications are enhanced strength. So if you're using it in concrete, it could improve durability, environmental sustainability by reducing the carbon footprint, thermal regulation aids in temperature control, waste utilization, reducing organic waste by creating biochar, reduced permeability helps in longer lasting pavement, and mechanical properties that enhances compressive strength. So how are these emission reductions calculated? And this is specifically for VM44. This is their calculation approach. So this is going to be the final equation that we'll see in this methodology for the emission reductions. However, there are many calculations that tie into this. So when we look at as one of those parameters, there may be calculations that are needed before we can get that final emission reductions at the sourcing stage. But this is just the final calculation that we'll be using in our policy to mint the correct amount of emission reductions there. So we can see that for this specific one, we have ERSS, which is the GHG emission reductions at the sourcing stage in year Y. So that's specific to the year that you are mentioning. Then we're going to add that with the emission removals at the production stage in that same year and subtract it by the GHG emissions at the application stage in that year and subtract it by the total leakage. And that's the equation that's mentioned in the methodology for the emission reduction. So we're going to move away from the methodology itself for just a second and talk about IWA properties. This is something that we've been implementing in some of our schema designs, and we'll get to see that in the VM44 schema design as well when we look at the Excel. So the IWA properties help us with providing a structured framework. The digital MRV or DMRV framework outlines a structured system defining terminology, roles, and evidence packaging for digital MRV solutions, enabling the creation of high-quality digital assets. It offers a standardized approach to processes and data models, ensuring consistency across diverse asset classes while allowing customization. It also helps us with the scalable asset creation by facilitating the generation of well-documented ecological assets at scale. This framework supports investments and ensures the production of high-quality digital assets. It accommodates various standards, protocols, and technologies, enabling the creation of robust projects ready for validation and verification. It also helps us with technical specifications, so intended for software developers, business analysts, and data scientists. The framework's technical specifications clarifies the data model and its entities. It details tokens, agreements, data extensions, and more, providing a guide for understanding and implementing the standardized approach. So at the bottom here, I've shown an example of one of the data types, which is going to be for co-benefits. These are the properties that could be used if you're trying to specify that a certain field is specific to a co-benefit. So we see two properties of the UN SDGs, and the second one is going to be a description. We've used the UN SDG that we can see in the Excel in a few seconds. But if you wanted to describe what that SDG is being used for in your project activity, then there's a property for that as well that can be added to the schema design and then added to the policy itself. So we could look at that schema now in our Excel. This is just an example of one. So here we have how we design our schemas, and we have these fields here that most of the time stay the same. So we have a required field, selective disclosure. If we want to allow multiple answers, schema type, properties, parameters, question, answer, and notes for our internal team. But if we go down, we're starting here with our project details section, and we can see the different properties that have been added. So these properties are coming from the IWA, and you can find these on their GitHub as well, the Inner Works Alliance. But at the very top, we have a section in this sheet for properties, and as you saw, the list goes on. Some of these were created by our team to identify certain aspects of a methodology, which we can call here an activity impact module. So their project start date, crediting period, monitoring period, geographic location like the longitude and latitude, or if we want to use GeoJSON. So going back to the mainframe here, we put properties in place for sectoral scope, for project type, project scale, geographic location. When we're looking to compare projects, this could be really important to see side by side. So if we're looking for a project that could have had a double counting case there, we could see that maybe that project falls in the same exact location. So they'd have side by side in that comparison the same geographic latitude, longitude, or even their GeoJSON information there, which we would be able to compare. We could also compare the accountable impact organization. If they have the same name, the same address, or the same owner, that could be really important for checking any double counting there, as well as looking at, is it the same methodology or is it including the same tools, the project start date, the crediting period, monitoring period. And like I mentioned before, we've used the co-benefits to identify what co-benefits that project had. There are also cases where, for example, here we could have activity impact module project scope, where a user named this as project scope and not sectoral scope. So when we're comparing it, it might not show that this is 100% the same just because there's a difference in vocabulary there or terminology. So using properties can help us with that. Since they're all standardized, we know that the same property is going to be used no matter what the terminal is for that specific use. Now going into the baseline emissions, these again are specific to VM44, and as you can see, we're taking into account certain sections in the methodology. Maybe we have notes for certain equations, and this is going to include all types of activities that methodology has. So if you're a user and you're filling out a form, you wouldn't be filling out this Excel. It would be the form within the Guardian. You can select your specific project activity so that we can get your emission reductions there. So this is going to be the VM44. We also have designs for tool 3. That's a CDM methodological. This is going to be used for parameters and again, you would be filling it out to your specific project activity, and we would have certain schemas there for you. So if you selected option A, then this is one you would have to fill out. You need these parameters. If you selected option B, then these parameters would be the ones you'd be filling out, but it would look different in the Guardian's form. And we also have tool 5 and tool 12. Now this is our policy workflow for VM. Like I mentioned in the checklist, you have different roles that you want to identify. So here we have 3 roles, which is going to be the project proponent, Verra as the standard registry, and the BBB. So once these roles have been approved by the standard registry user, then the project proponent would create a document, as a project design document, where they would fill out things like project details, baseline emissions, project emissions, leakage, emission reductions, or any tools that were used. For example, here we have tool 3, 5, and 12 that will all be included in the PDD. Then they would submit that, and the project would be added to the project pipeline by Verra. As you can see, this is the pink color that Verra has as their role. Then the BBB can review this, and they have the option of approving or rejecting the PDD. If it's rejected, then the project proponent would have to go back to this step and resubmit. But once it's approved, then the project activities begin monitoring. This is something the project proponent would do, and they would fill out a monitoring report at the appropriate time. And this is going to be based off of the VM44 guidelines of what they need to monitor and at what frequency. Then the fields related to logical tools should also be updated as per their guidelines. That would be submitted by the project proponent, and the BBB again has the option of approving or rejecting that once they reviewed the document. So if they approved it, then the project would be added to the project registry, and Verra would do their final review and issue the VCUs if it's approved. So those are going to be the steps that we're about to see in this demo. So I wanted to start off here where we have our policy workflow engine, and you can see that there's certain parts here like our choose roles block, Verra header, project proponent header, and the BBB. These are the different roles. If we were to open these up, then you'd see all the steps that I described in that workflow. But we have certain blocks that you could use here. You also see this is going to be for modules. We have one for tools. So if we were to click on the tools, we'd see the ones that are included in this one, which would be tool 3, 5, and 12. So we're going to continue here, and we're going to select go. Then we're going to create a user, which is going to be the project proponent. You have to assign the role there and select OK. And the project proponent's going to select new project, where they get to fill out all that information that I was talking about in the Excel. So this is the project details section. We're looking at the GeoJSON now, where they can select a certain point on a map. You could also provide the coordinates instead. And then we have more information that's specific to the project participant or project proponent. This was one of the ones that we mentioned would have a property of the project start date, the project crediting period, and monitoring period. And these are just demo values. So when we see the final mint on this, that's not going to reflect an actual project. So then we move into the specifics for VM44, where you could select a high technology production facility or a low technology one. And that's going to change the different fields that you'd be filling out. So you want to make sure you select the correct ones there. Depending depending on some of these responses too, would depend on what tools you have to fill out. So for leakage, for example, there's one, let's say if you said yes, then you would have to fill out tool 12, and that all is recorded here. And as I mentioned in the Excel, when we look at this form compared to all the parameters we have listed out in the Excel, it's a very simplified version, although it includes all the information we would need to make the proper calculation to get our emission reductions at the end. And the project proponent would select create, and we'll be creating another user, which is going to be the VBB, and we have to assign a role to the VBB. And once we select OK, then the VBB would provide their name. So now we're going to navigate back to the standard registries account where they can approve the VBB and go to the project pipeline and add this project to the project pipeline. We're going to go back to the project proponent where they're going to assign the VBB, and now the VBB has access to that PDD that they just filled out. So by clicking on projects, they can select view document and either validate or reject. The project proponent would fill out the monitoring report by clicking add report. So this is dependent on the monitored parameters in the methodology. So VM44 would specify which parameters need to be updated and how often they need to be updated. And you'd fill that out here, as well as any parameters for the tools that need to be updated as well. Then we'd go back to the VVB where they can select monitoring reports, and they could also view that document and select verify or reject. And the administrator, which is the standard registry, would then also select monitoring reports. They could also view that document. They'll see everything there, including all the auto calculations that happen that you didn't see in the PDD when you're filling it out. And they could select mint, and we can see all the information in the trust chain. So this is going to be what we call our VP that has all the VC files here as those cards on the bottom. And we could see every single step that was taken by each role. So here we see the policy was created. So we'd also have stuff like the monitoring report was verified all the way to when we mint these VCUs. And you can select each one. Each VC file is available for each step or card here. So we're going to see the monitoring report one. It's going to have all the information that you filled out, as well as all the auto calculations that occurred. And then finally, we have the mint VCU step as well. So if you want to see the VC file for that, you could on this VP. So we're going to go ahead and open up for any question. You could also submit questions to our Discord or directly to Envision at our email at info@blockchain.com. And for more information about the Guardian, you can follow that link to our hub. All right, well, thank you all for joining, and I hope to see you here again next month.